Good morning. So let's do here some examples, right? First of all, I will solve what is between parentheses. I need to find the MMC between 1 and 2, and that's 2. 2 divided by 1 is 2. 2 times minus 1 minus 2. 2 divided by 2 is 1. 1 times minus 1 minus 1 times. Here I have minus 1 over 2 to the square. So minus 1 over 2 times minus 1 over 2 is going to be plus 1 over 4. Okay? Now I subtract here minus 2. Minus 1 minus 3 over 2 times 1 over 4. Multiplication of fractions. Numerator times numerator, denominator times denominator. Minus 3 times 1 minus 3. 2 times 4, 8. Okay, so that's my final result. In the second example, I need to find the MMC here between 1 and 64, which is 64. And then I have the square root. 64 divided by 1 is 64, times 1 is 64. 64 divided by itself, it's 1, times 17, 17. Times, again I need to do the MMC here, between 9 and 1 is going to be 9, and then 9 divided by 1, 9, 9 times 3, 27, 9 divided by 1 is 1, times 94, 94. 64 plus 17 is gonna be 81, and then I repeat the denominator, times 27 plus 94, right? 11 goes 1, 11 then 12 over 9. Fortunately, I have the exact square root. The square root of 81 is 9, because 9 times 9 is 81. The square root of 64 is 8, because 8 times 8 is 64. The square root of 121 is 11, and the square root of 9 is 3. So I can simplify here by 1, divide by 3 is going to be 1, and here 3. I will have 33 over 8, okay? That will be my final result. Let's move on. The picture was split in 8 equal parts, okay? Then it determined the expression that represents, letter A, the area of the square, okay? So if I'm thinking about the big one, this side is also y, so the total area is what? Y to the square. But if I want a square like this one here, this area here of square, this area is y over 2, the side, yeah, and then y over 2. And in this case of the little square, there is going to be y over 2 to the square, y to the square over 4, right? The perimeter from the square that delimitates the picture. If I think about the big one, right? So the total area is going to be y plus y plus y plus y, 4y. But if I think about the small square, that's y over 2, I will have y over 2 times 4, which will give me 2y, because I simplify 4 divided by 2. Then the area from the orange part. So the orange part, there are 2 little squares, right? I saw the area of the little square is y to this the square over 4, so 2 times y to the square over 4 plus half of this area. So this is y to the square over 4 over 2, which gives me 8, right? So I'll have 2y squared to the 4 plus y to the square over 8. And I need to find the MMC in this case. The MMC between 4 and 8 is 8. 8 divided by 4 is 2. 2 times 2 is 4. 8 divided by 8 is 1. 1 times y squared is y. 4 plus 1 is 5y to the square over 8. Okay? And then now determine the numeric value for the area for y equals to 1.2. So if I think about the big square, which the area is y to the square, and I put 1.2, I'm going to have 1.2 to the square. I need to do this multiplication, 1.2 times 1.2. I'm going to multiply normally, as I didn't have comma. 2 times 2, 4, 2 times 1, 2. I jump on house and then 1 times 1, 2, 1 times 1, 1. 4, 4, 1. How many digits I have after the comma? 1, 2, 1, 2, and I put the comma. So the total area is going to be 1.44, okay? Here, indicating the mass in grams of each object determined by x, determine the equation that corresponds to the representation in the balance. So in the left we have 5 boxes and each one has the weight of x, and this must be equals to total of grams in the other side, which is 500 plus 100. So 5x must be equals to 600. X must be equal to 600 over 5, which will be 120 grams each block of it. Okay? Then we have honey, right? And they say that the weight of each honey is m. He wants that we discover the equation that represents the balance, and also let's find the value of m, of the honey's weight. Okay, so I have m plus 50 equals to m plus 200, and then m plus m is 2m plus 50 equals to m plus 200. Let's change this m for here and this 50 for there. Remember that when we go to the other side, we change the operation. We put the inverted operation. If m is adding here, it goes with minus 200. 50 is adding, it goes minus 2m minus m is m. 200 minus 50, it's going to be 150 grams. So each honey bottle or package has 150 grams. So each side of the balance has 350 grams, okay? Then calculate the x, knowing that the universe is the rational numbers. Rational numbers are numbers that can be represented by a fraction. So distributive, 5 times 2x, 10x. 5 times minus 1, minus 10, equals to 2 times x, 2x. 2 times 4, 8. I have to let x by one side and numbers to the other. So 2x here is going to the left. So 10x minus 2x equals to 8. 10 here is minus, subtract goes adding, plus 10. 10x minus 2x is 8x. 8 plus 10 is 18. X is equals to 18 over 8. I can simplify by 2, and it's going to be 9 over 4. Okay? And this is in the rational numbers, right? Here, I repeat, 10 minus 2 over times x, 2x. 2 times 3, minus 2 times 3, minus 6. equals to 8 plus 3 times 2, 6s. 3 times 5, 15. Let's let x by one side and numbers to the other. So first of all, 10 minus 6 is 4, minus 2x equals to 6x plus 23. 6x to the left, minus 2x minus 6x equals to 23 minus 4. So minus 8x, because I have minus 2, minus 8 minus 6 is go minus 8. 23 minus 4, it's going to be 19. So x is equals to 19 over minus 8, okay? And also, it's a rational number. So if I want to write, I can say the solution is minus 19 over 8 in this case, and the solution here is 9 over 4. Let's move on. We have 10 boxes, and we did 2 piles, okay, of the same height as the picture shows. In some boxes, I have put a stamp with the number indicating its height in centimeters. The boxes without the stamp have the same height. So if this has x as height, this has as well, and those others too. Every box without stamp has the same size of height. So I will say that its height is x. Calculate the height from these boxes without stamp. So how do I do it? I get here and I put here the total height is going to be 16 plus 14 plus 3x, and these total heights must be equals to the other side. So 15 plus 13 plus 12 plus 2x, right? 16 plus 14, 30, plus 3x equals to 13 plus 12, 25. 25 plus 15, right? 40 plus 2x. Now I will do it that x in one side and numbers to the other. So 3x minus 2x equals to 40 minus 30. So x is equals to 10, okay? So each box of it has the height of 10. Then we need to reduce by the equal terms. X, I just can join with x. So I'll have 3 over 2x minus 1 over 3x. Then plus 1 over 4y plus 2y. I have to find the MMC. The MMC between 2 and 3 is 6. 6 divided by 2 is 3. 3 times 3x, 9x. 6 divided by 3 is 2. 2 times minus 1x minus 2x. Plus, here is over 1. So the MMC between 4 and 1 is 4. 4 divided by 4 is 1. 1 times y is 1y. 4 divided by 1 is 4. 4 times 2 is 8y. 9x minus 2x, 7x. Plus y plus 1y, 9y over 6. Over 9, sorry. Over 4. But in this case, I can put them in the same denominator, but I cannot join, yeah? I can put in all the same denominator. So it's gonna be 4. 4 times 7, 21x, plus here is gonna be 6 times 9, 36y, and that's all. I cannot do anything else than that, okay? And the maximum simplify, but I cannot add x and y. So now I'll do here the distributive property. Minus 2 times 2, 4. X times x, x to the square, and repeat y. Plus minus 2 times 1 minus 2 x, y. Minus 2 times minus 6, minus and minus is plus. 12xy. Minus 2 times 7y minus 14 x squared, and minus 2x times 6 minus 12x. Let's see if we can reduce some terms. Minus 4x minus 14x square minus 18x square minus, no, sorry, there is y here, I didn't see. So here xy, I don't have other the same, so minus 4x squared y minus 2xy plus 12xy plus 10xy minus 14x squared minus 12x. I cannot reduce anymore, okay, because they are different incognites. I don't have the same representation each one. Now, in a math game, a group from Carlos proposed the group to Everaldo the following question. The double of a natural number added by 20 is equals to the add of this same number plus 15. Which number is this? So, the answer was 5. Everaldo and its group got it by Carlos. The question, let's see. 2x minus x equals to 15 minus 20. 2x minus 1x is x. 15 minus 20 is minus 5. So the answer is minus 5. It's not 5. So no, they didn't. They were wrong. The right answer was minus 5, okay? Now, verify if minus 5 is the square from the equation below. So I'll do 2x minus 3x equals to 10 minus 15. 2 minus 3 minus x. 10 minus 15 minus 5. So x is equals to 5. So no, it isn't. It isn't the square from this equation. The square is 5. Alright? To verify if minus 2 is the square of this equation. So I will put everybody over 6 because the MMC, right? And now check. 6 divided by 3, 2. 2 times y, 2y. 6 divided by 2, 3. 3 times y, 3y times 1 plus 3. 6 divided by 6 is 1 times 5, 5. Here is over 1 divided by 6 is 6. 6 times y, 6y. So I'll have 2y plus 3y plus 3 equals to 5 plus 6y. 2y plus y, 5y plus 3 equals to 5 plus 6y. So 5y minus 6y equals to 5 minus 3. So this is going to be minus y or equals to 2. Y equals to minus 2. So yes, it is the answer, okay? Now, how much is 25% of 3 over 5 of 1,200? So I can simplify here by 5. Here is going to be 5. I can simplify by 100 here. I can simplify by 100 here, right? So I'll have 5 times 3 times 12 over 1. Yes? Then I will have 5 times 36. 5 times 36, 30 goes 3. 5 times 5. 5 times 3, 15 plus 3, 18. Okay? How much is 30% of a number that equals to 810? So 30% of a number, it's equals to 810. What number is this? So I'll do 30x equals to 800 times 100. I put 2 zeros again, so 81,000. So x is equals to 81,000 divided by 30. I can simplify by 0. I have 8,100 divided by 3. This can be simplified by 3. It's gonna be 27. Okay, so this number is 2,700, right? And that's it. Thanks.